Hey guys, welcome back. So in the last video, we talked a lot about inequalities. Now we're going to talk about compound inequalities. So what does the word compound mean? What does the word inequality mean? And what they mean together? Well, the word compound, usually when I think of the word compound, I think of the word two. Word inequality, well, we talked about that in the last video. Inequalities are expressions with stipulations for the solution. So expressions with stipulations for solutions. Let me pull that up so you can see all of it. So inequalities are going to be expressions for stipulations for the solution. And finally, if we put them together, a compound inequality is going to be two inequalities for stipulations for a solution to an expression. So it's going to be two inequalities or stipulations for a solution for an expression. So today we're going to talk about them. Most commonly you're going to hear them as and or inequalities. Okay? Our essential question for the day is what are compound inequalities and how are their solutions represented? So I'm going to go ahead and give you the answer and then we're going to learn why it's the answer. Compound inequalities are known as two or more inequalities. And solutions are represented on a number line. So, two or more inequalities would be a compound inequality, and for solutions for compound inequalities, we put them on a number line. Awesome. So here is your guide to and or inequalities. We're going to start by talking about and. So if you have an and inequality, it's going to use the word and, where both inequalities that you're given are going to be true. A solution to the compound inequality is going to be a solution to both inequalities. So a solution to both inequalities. So in and inequalities, both have to be true. The compound inequality sorry about that. Compound inequality graph is going to be called the intersection of the graphs. Because it's when we think of an intersection, we think of where two roads meet. So it's going to be where the two solutions to the different inequalities meet. This intersection is going to be the overlap of our answers. So, and I want you to think both are true. It's called an intersection. Now let's talk about or. This means one or both could be true. One could be true. Both of them could be true. As long as one of those conditions are met, then an or inequality is okay. So the solution to a compound inequality is a solution to at least one of the inequalities. So you need to be a solution to at least one of them. So for or, either one or both must be true. So what we're going to call there answer is not intersection, but instead we're going to say the compound inequality graph is going to be called the union of the graph of the two inequalities. So a union is a combination of all possible answers. Because all of this, even though there's two inequalities for both and or, are all going to be created on one number line. So an example that I want to show you that I hoped my kids understand in class was, with our ands, think about it must satisfy both. So if I told you that I wanted you to get me French fries from McDonald's and a Whopper from Burger King, if you only bought me French fries, it didn't satisfy both my wants. If you only bought me McDonald's, only bought me a Whopper, it doesn't satisfy both. You have to do both. However, or at least one. So if I said, hey, could you bring me either French fries from McDonald's or a Frosty from Wendy's? If you bought me a Frosty from Wendy's, you works. You brought me at least one. If you brought me a large fry from McDonald's, it still works because you brought me at least one. And if you brought me both, it's still at least one, so it works. One or both. Alrighty. So let's jump right in. So for our little intro to inequalities, we have a really fun painting thing. So since Hannah has some blue paint, she wants to lighten the shade, so she mixes in 1 cup of white paint. The color's still too dark, so Hannah keeps mixing in 1 cup of white paint at a time. Well, after she adds 4, she decides that it's too light for her. So first things first, she's adding in 1 cup of paint each time. And after 4 cups, too light. After 1 cup, still too dark. So what we're going to do is answer a couple questions about this little bit of a situation. A says, explain in words how much paint Hannah should have added initially to get the shade she wants. Well, let's look at it. At 1 cup, there isn't enough. It's still too dark. But after 4 cups, it's too light. I should have added more than 1 cup, but less than 4. So that's what we say in words. Hannah should add more than 1 cup, but less than 4 cups. Okay, cool. We figured out how to say it in words, but let's model it with an inequality, because we can do this. Well, what we know is we're going to let our P stand for the amount of paint she's putting in, right? So then we need P to be greater than 1. Why wouldn't it be greater than or equal? Well, if it was equal than 1, then when she put in 1, it should have worked. But remember, she said once she poured in 1 cup, it was still not light enough. Then we also need P to be less than 4. Same reasoning. It can't be equal to 4 because when she puts 4 in, there's just way too light. So this is going to be an and inequality because all the numbers between 1 and 4, if you chose 2, it's greater than 1, it's less than 4. If you chose 3, it's greater than 1, less than 4. It's got to meet both of these requirements. Alright. So Hannah decides she likes the shades of blue that appear between adding 1 cup and 4 cups. That big word between there is going to be important. How can you represent the number of cups of white paint that yields the shade she prefers? So one way we can do it is by what we've already wrote down. Look at B. We have that and inequality. But another way that you will see and inequalities written, mostly when they use the could be like this. P could be in the middle. Then our boundary is, what does it need to be less than? What does it need to be more than? Well, it needs to be more than 1, but less than 4. So this is a way that we can express that inequality. Not too bad for our intro to our compound inequalities. Alrighty. Let's get into some actual fun. So before I can hand you an inequality and tell you to just go for it, go get it and do it, you gotta understand it. So it says, how can you use inequalities to describe the sets of numbers graphed below? Well, look, there's our definition. A compound inequality is made up of two or more inequalities. Yay! I always like to point out our definitions. It wants us to write an inequality to represent the solution shown. Well, we know there's at least two, so let's zoom in and take a look at those. So look at this first one here. We know that all of these numbers this way are going to be less than -3. So whenever we're solving something, we know that we're going to have an x, which are all the numbers that the arrow is touching as it goes on. And we know that we're going to have a 3, which is what the dot is, whether it be open or closed. So now that we've wrote our x and we've wrote our 3, all that's left to do is figure out what sign goes there. Well, first things first, we know it has to be equal to, because that's a closed dot, right? Well, all those numbers are less than 3. So x should be less than or equal to 3. I want you always to think about the numbers that are being sent with the arrow as x, because it could be any of those numbers it's touching. Alright, cool. We figured out one of them. Let's figure out the other one now. We'll take a look. We know that these numbers that the arrows are touching is going to be x, so we're going to have an x. We know that it starts at 2, so we're going to have a 2. And we know that it's going to be a less than or a greater than because of the open dot. So all those numbers that arrow is touching by pointing to the right are going to be bigger than 2, right? So we want a x is bigger than 2 there. Okay, awesome. We're almost done. Now to decide if this can be an and or. Well, is there any numbers that can be both less than -3? I noticed that I didn't put my negative there. There we go. Fix that real quick and easy. That can be less than -3 and greater than 2. There are not. These guys aren't touching. When you have two that shoot away from each other, you are dealing with an or. So, it can be one or it can be the other. So this is an or. So our solution must satisfy one of these. So let me zoom out some. We got to satisfy one of these. So my question to you is, well, what type of solutions can we have? If I said that x was equal to 7, would that work? Well, 7 is greater than 2, but it's not less than -3. But does that matter? Or says at least 1. It does satisfy this one, so it works. Okay, I got you. Let's try another one. Let's try x equals -100. Well, it's definitely not greater than 2, -3. So since it at least works for 1, we can say, yeah, that could be an answer. Now, what about if I said x equals 0? Well, alrighty then. 0 is not less than -3, and it's not greater than 2. Since it doesn't meet either of these, we can say that's not a solution. Not a solution because does not satisfy either. So x equals 0 can't work because it doesn't satisfy one of those. Alright, so these are your basics for the ors. Now let's talk about our ands. Well, notice, it may be a bit hard to see there as my kids pointed out in class. So I'm going to go ahead and color this in a little bit red to show you where the line actually is. So hopefully that helps. So the solution shown. Well, we always know that in the middle here, this is our x, right? So we got an x, and we got a -4. And we got an x, and we got a 1. Let's start with the first part. Well, here's -4, and it's shooting this way. Well, the numbers that it's pointing toward are always going to be bigger than -4. So greater than, and we have to use an equal to because that's a closed dot. Okay. Now notice, here we are starting at 1. It's shooting that way. So the numbers that we're going toward from the 1 are less than. So we can use less than. We don't need an equal to because that's an open dot. So we have x is greater than or equal to -4. X is less than 1. And notice, all of the answers are connected. So if you have them where they connect, this would be considered an and. Because any answer you choose here will work for both. So our answer must satisfy both. So just like with or, I want to give us a couple of examples. If I said x is equal to -2, would this work? Well, -2 is greater than -4, and it's greater than 1, or it's less than 1. So, check. Yes, that could be an answer. What if I said x is equal to 3? Well, look, 3 is greater than or equal to -4, but it's not less than 1. And remember, we gotta satisfy both, so no. We kick him out because not less than 1. Okay, let's try one more. X is equal to -5. Well, it definitely is less than -1, but is that bigger than -4? Nope. Gotta meet both, so no. Not greater than -4. So with ands, you gotta answer both of them. You gotta work for both. You're going to McDonald's and you're going to Burger King, and you gotta bring me both or it doesn't work. For ors, it's gotta do one. So you can give me a Frosty or you can give me a French fry. I'm happy with either, as long as it works for one. Alrighty. So I'm going to briefly show you the next one, but I'm not going to go over it because remember, these are videos I'm trying to keep slow, and this one's going to be longer, I can already tell you. So, you have a show your learning. So if you are trying to learn and you are at home because you missed a day or something, take a second, see what you think. Try it out. I will go ahead and color this a little bit because they are like that. And tell you that this is a closed dot and the other one's an open dot. So it just wants you to write what the compound inequality is. I will show you what I got. This is what we did in class. It is definitely an and there you go. I'm not going to spend a lot of time on it for sake of time. Alright, so now let's get solving. That's our favorite part, solving. So with solving, with or inequalities, solve two inequalities. So you're just going to have to solve two separate inequalities. So notice it gives them to you. Let's do it. Well, it gives you 5x plus 7 is less than 13. So we're going to write that here. Or it tells you negative 4x plus 3 is greater than 11. Alrighty. So now we just solve these like we did in the last video. You guys know how to do this. We're trying to get x on one side all by itself, number on the other side of the sign. So subtract 7, because SADMEP still applies here. Then 13 minus 7 is 6. So now what? To get x by itself? Divide by 5. So we get x is less than 6 over 5. Fractions are okay. They're our friends. Okay, alright, we solved one of them. Now we gotta solve that other one. So, here we're gonna subtract 3. Bring down what we don't use. What's 11 minus 3? 8. Divide by negative 4. Divide by negative 4. X. Uh-oh, we divided by a negative, which means our sign has to flip. We still have to follow the flipping the signs rules. And we get a negative 2. Alrighty, we got this. But remember, we don't just say, hey, here's the answer. We actually have to graph that bad boy. So I'm going to put our graph down there. Here's our little number line. We're going to put us a little 0 in the middle. This is 1. This is 2. -1, -2, -3. Alright. So, we know that we need to have an open dot on -2. So let's put that open dot there. We also need an open dot on 6/5. Well, what is 6/5? There is absolutely nothing wrong with you turning that into a decimal because decimals are easier to put on the number line. So if we go ahead and rearrange that and put that as a decimal, we get 1.2. So we go to about 1 a little bit after. I know you can't get exactly 1.2, but a little bit between 1 and 2 is enough for me, just like when we were solving them in the last video. So now what we're going to do is we need less than -2, so we need to go this way. We also need less than 1.2, so we need to go this way. So notice the solution for x is less than 1.2 works for all of it. Sometimes you will find that you don't really need to pay attention to the other one. You still should graph both to see where it goes, but sometimes you're going to notice that this is the only one that works, that we could ignore x is less than -2. Because -2 is an answer. It may not work for this one, but it does work for that one. And remember, our rule is at least 1. Alrighty, that's an R. We're not going to do the show you're learning. You guys try that out on your own. I always have the answer keys in my book, our big math binder that we all shared to know how our binder should look. You can always check it out there. Let's jump into solving an and. Well, when solving an and inequality, there are 2 ways to do it. We're going to do way 1 first. So with way 1, what you do to the middle, you do to the other sides. Your goal is x alone in the middle. Alright, so let's take a look at what they give us. They give us a -12 less than or equal to 7x plus 9 less than 16. Okay, our goal is to get x alone in the middle. What we do to the middle, we do to all sides. Well, to get x alone, the first goal is still to subtract 9, alright? Side map still works, so we subtract 9 there. But we also have to do it here and here. Well, -12 minus 9 is -21. We have our 7x in the middle because we bring down what we didn't use. And then we have 7. X is still not by itself. To get x by itself, we divide by 7. Yes, you still have to flip the sign if it's negative, but here we don't have a negative. So 7, 7, 7. X is now alone with a 1 and a -3. So that's our answer. This is way 1. The second way you can do it is you can break it apart. So here's way 2. Break apart and solve. So what you would do is act like this guy didn't exist and just write what you see. So -12 less than 7x plus 9. Then you do the same thing. Act like that guy didn't exist and write what you see. 7x plus 9 less than 16. Now you have 2 different ones, and it is an and, so you just solve it out. Well, if we do that, subtract 9, You're going to get negative 21 less than 7x, divide by 7, divide by 7. You're going to end up with negative 3 less than or equal to x. Over here, you're going to do the same thing. So no matter which way you do it, you're going to get the same answer. You still got to be bigger than negative 3 and less than 1. I recommend doing it the way it's given. If it's given to you written like this, then do it. If it's given to you with the word and, break it apart and solve. So solve in way given. But we haven't finished this. We got to solve and graph. So let's graph it. Okay, 0 in the middle, 1, 2. Then we got negative 1, negative 2, negative 3, negative 4. There we go. So we have a closed dot at negative 3, right? Because here, if you're looking at this one is what this says is x is greater than or equal to negative 3. Over here, you have your greater than in there. So closed dot there. And at 1, we have an open dot. Because whether you're looking here, where you see the open dot, or you see here, where you see the sign that says open dot, you have an open dot. We want the numbers that fall between the two. We want it to be both bigger than negative 3, so going this way, and less than 1, going this way. So your and inequalities are going to usually meet in the middle. And there you go. We did it. Yeah. All right. So like I said, this video is going to be a bit longer than usual. It's okay. It's fun. This is a new concept. This is what I was talking about when I say if you have it and it gives it to you in ands, because it won't always be the same thing. These are two different inequalities, but you still have to meet both. When you solve it this way, what I want you to do is to just break it apart and solve it, because you can't put it together. So I'm not going to write it all out, but I will project what we did in class. I wrote this one, I wrote that one. We went ahead and solved it just like a normal inequality, and it ends up being graphed just like a normal inequality as well. Alrighty. Now, of course, you know we can't go anywhere without trying out a word problem. So example 4 is a word problem. Enrique plans a diet for his doggy, River. River consumes between 510 and 540 calories a day. 1 1/2 servings of dog food every day. And we don't know how many treats she can have. We want to know. Well, notice it tells us there's 320 calories in that dog food. And every treat is 15 calories. So, remember, in order to solve word problems, we have to figure out what our x is first and then go from there. Well, you need to let your x be whatever you're looking for. So let's let x be the number of treats River can have. So x is our number of treats. Well, then now let's put together what we know. Well, she has 1 1/2 servings of dog food, so 1 1/2 dog food. Plus, she has X treats, because we don't know how many treats she has, right? So we figured out that part. Let's go ahead and break this down a bit. We know that it's 320 calories in dog food, so 1 1/2 times 320, plus there's 15 in our treats. So if we want to know how many calories, it's 15 times however many treats we had, right? If you type this in your handy dandy calculator, you're going to get 480 plus 15x. Alright, we're almost done here. Except for we haven't taken into consideration what is it that we have to set this equal to. Remember, our steps for solving an equation are define your variable by what you need to know, figure out what we know about it by creating an expression. We did that. Now we need to find what we need to set it equal to, or in this case, less than or equal to. Well, it says between 510 and 540. So, we need to be between. Whenever you see between, it's automatically going to be an and inequality. Less than or equal means that we can get 510 or we can get 540. So let's go ahead and put 510 here. Because we want all the foods and stuff to be greater than or equal to 510, but we don't want to go over 540. So all the food here in the middle needs to be less than or equal to 540. Well, we already came up with the expression 480 plus 15x is the food that we get every week. The only thing left to do now is solve. Remember, how do we solve things? In the middle, well, we're trying to get x alone. So minus 480 on every side. Okay. So we end up with 30. Bring down that 15x. We haven't used him yet. Bring down your 60. Okay, x needs to be alone. So we are dividing by 15 on all sides. Cancel. X. 60 divided by 15 is 4. 30 divided by 15 is 2. So we have between 2 and 4. Not too bad. We don't have to draw a graph for this one, but we do have to make a sentence because this is a word problem. So she can have between 2 and 4 treats. You may also see this written as she can have at least 2 treats, but at most 4 treats. There are multiple ways you could write this. As long as you're telling me 2 is the least amount, 4 is the most amount, I'm good with it. All right. On the next page, it just changes the type of treats that we have. If you need the answer to this, and if you're not in my class, you can always come take a picture of it. I have it. Or you can try it out yourself and see how you do. Here is what it looks like at the end. I'm only going to leave it there for a second. Alrighty. Now, let's do a quickie review. I'm not going to go over this too much, but I do want you to see it. So for the first one, we are matching inequalities. The whole point of this is to help you see that if you have an or, they're usually going to shoot away from each other. If you have an and, they're going to be connected. So look at our first one. X is less than negative 4. X is greater than 3. So we need an open dot and a closed dot, so that kicks this guy out and this guy out, so it's got to be one of those. And then we need less than negative 4, greater than 3. So it has to be this one here. All right. So we would combine them just like that. So let me show you the answer key so you can see it real quick. Stop and talk and see if you can understand why. Come to me if you can. All right, let's take a look at the next one. Sometimes you're going to be asked to write inequalities from an expression. So it says all real numbers that are less than negative 3 or greater than or equal to 5. So less than negative 3, that means our negative 3 would go here. Our or would be in the middle, and then our 5 would be what it's greater than. Okay? And then the next big thing I want to point out is a certain recipe for a ham to bake between tells us it's an and inclusive tells us what sign to use. If anything ever says inclusive, it means that it is a equal to. So less than or equal to, less than or equal to. Alrighty. Finally, remember that with and inequalities, it has to work for both. So our and inequality is b is greater or less than or equal to 4, and also greater than negative 1. Negative 3 is less than 4, but it is not greater than negative 1. So this would be false. 3 is a solution for a compound inequality here. Well, let's see. It's bigger than negative 3, but it's not less than 2. So this would also be false. The biggest point here is that and inequalities, it's got to work for both. All right. Let's take a look at these. You guys know I love my errors. So Libby did something wrong here. And I want you to describe and correct that error. Well, always pay attention to what the word tells us. The word or she's solving an OR inequality. So, like, when my class did this, they really worked hard at her math, and they were like, what did she do to get here? And they were looking for a math error. But when it comes to inequalities, it doesn't always have to be a math error. Everything Libby does here is fine until you get to her graph. Look at her graph. This is an and inequality. When it says that it needs to be greater than 2, she shoots it the wrong way. So it should look like that. She created an and when she needed an or, and her graph should look like this instead of that. So, if you're on your state EOC or anything you're looking at test-wise or homework-wise, because I always have an error problem with my homework, then always make sure that it's not always going to be the math. Check the graph. Check that they are plugging in the right thing. Did they use the right word? Because sometimes it's not just going to be the math. And that's where they love to throw at you kids. They love to say, what's the issue? And you spend so much time looking at the math that you don't even think about, maybe it's the chart or the graph that's wrong. Alright, guys. That's all I have for you in this lesson. I hope y'all have a great day. Sorry, I'm about 6-7 minutes over. But hey, that's better than 20-30 minutes over. Have a good day. See you next time. Bye.